In the previous lecture, we had discussed about sun tracking. In this lecture, the specific outcome is solar radiation database. After this lecture, all have to submit an assignment for solar radiation database. Now, let's all go into the session. This solar radiation database is important for estimating the PV performance or the generation of electricity at a particular place or location before the solar panel is installed. As we have already discussed, there are many websites to analyze the solar radiation database. Here I have listed some of the websites for solar radiation database. Photovoltaic Geographical Information System, National Solar Radiation Database, Meteorological Data from NASA, and so on. In this, some websites are free of cost and some websites are paid to get the solar radiation database. In this, I am going to explain about PVGIST, Photovoltaic Geographic Information System. This website is free of cost. Let us now analyze solar radiation database in the website. Watch this clearly. After I have completed, you have to submit an assignment for the particular place where you are staying. In the Google page, type PVGIST tool. Open the first link shown here, PVGIST. It takes about few minutes to open this page. This is the home page of a photovoltaic geographical information system. This is a free website to analyze solar radiation database. You can find the solar radiation database for any particular place throughout the world. India, Africa, Australia, Singapore, wherever you want to find the solar radiation database, we can find by using this website. This is a world map. You can move or drag to the particular place where you want to go. So I'm going to come to India. You can select like this. So this is one method. Another method is, if you know the latitude and longitude, type the values here. If you don't know that value also, doesn't matter. You can type the place where you want to find. Here I am going to find the solar radiation for Coimbatore. Type here Coimbatore. And click go. Automatically this will come to the point junction, Coimbatore junction. So in this, automatically the latitude and longitude will be selected. 10 and 10.99 and longitude is 76.94. Your elevation will be changing from place to place. Here we have many things to analyze. So here is the grid connected system, tracking PV system, off-grid system. These three things will be discussed later. So we'll go into the solar radiation. So in solar radiation, we can find from monthly database, daily database, and hourly database. Here I'm going to discuss about monthly database. Here the solar radiation data is available from 2005 to 2016. After that, it has not been updated. So by using this data, we can analyze. If you want to find the solar radiation analysis for the past years, so select the starting year. So if you want to find for 2010, click 2000 year, starting year, ending year also, click just 2010. For 1 year, the data analysis will be shown here. Here, the solar radiation database is selected for the year 2010. For this particular year 2010, monthly radiance can be calculated by selecting the following parameters. For the monthly data, irradiance are global normal irradiance, direct normal irradiance, global irradiance optimum angle, global irradiance angle. So in this, I'm going to select the angle as 20 degrees. And average temperature. These are the parameters available in this website. So after selecting these parameters, you can visualize the results by clicking the visualize results. Here you can find it. Here the results are displayed. So the radiations which we have selected will be shown here. In x-axis we'll be having the year, month-wise report. In x-axis we'll be having the month, January, February, March, April, up to December we'll be having. In y-axis we have monthly radiance, kilowatts per meter square. So we can analyze this one by one. So we can select these parameters one by one. This is the horizontal irradiance. In January month, horizontal radiation is 177.87 kilowatt hour per meter square has been generated on an average. This is in February, March, this is in April, May, goes on like that. This is your horizontal radiation. This one is a direct normal radiation. So we have already discussed about these things in the previous class itself. What is horizontal radiation? What is normal radiation? So in normal radiation, in the month of January, we will be having 200 watts per meter square and goes on like that. So these are the parameters available for here. This is the optimum angle radiations. This will be your selected angle irradiance. By selecting these parameters, we can analyze the monthly solar radiations and can be estimated for generating the electricity. So we will find the temperature. Click this. For January month, the average temperature is 25 degrees Celsius. In March, the average temperature is 26.6 degrees Celsius. When you go to July, it is 24.4 degrees Celsius. So the average temperatures keep on changing. We can analyze this. So after this, we can create a report by converting to PDF. If you click this PDF, the report will be generated in PDF format. This is the report generated for the year 2010. We can analyze for every month. So we have selected latitude, longitude for Coimbatore as a calculated databases. Starting year is 2010 to ending year also 2010. So we have the selected parameters are global radiation, normal radiation, global irradiance at an angle 20 degree, and average temperature. So this has been analyzed, shown in the graph PDF format here. You can find the global radiation monthly wise, January, February, March, April, December. This is also for direct global radiation monthly wise, global irradiance optimum, and global irradiance at an angle of 20 degree has been shown here. Now this is your monthly average temperature generated here. So average temperature in January, February, up to March has been calculated here. This is a report generated in PDF format for the year 2010. In the same way, we can calculate for daily solar radiation by clicking this. So in this, I'm going to find the daily solar radiation for a fixed plane, not for sun tracking, only for a fixed plane I'm going to fix. I'm going to select the month here. Okay, which month we want, we can select it by month. So I'm going to select for June. I'm going to select for the month of June. So I'm going to use the time as local time. So this is a local time, this is nothing but for Indian timing, I'm going to assign the solar radiation. So I'll click this and daily temperature variations. And after selecting these parameters, click the visualize results. You can find here for a fixed plane I have selected, the radiation is going on that. So approximately averagely, this is your first one is your global radiation, second one is your direct radiation, and third one is a diffuse radiation. The solar radiation starts from east to west, begins from 6 o'clock and ends at evening 6 o'clock. So the maximum radiation will be at 12 noon. So global radiation is approximately 652.24 watts per meter square at 12 noon in the month of June. So every month it will be changing. For example, I have selected here I have selected for a month of June. So let me change again. If I select May month and visualize result, here the value will be changing. Here it has been changed. The value is nothing but 814.79 watts per meter square. Previously it was 600 something, but now it has been changed to 814, this is a global radiation. The same way the parameters can be analyzed. For the month of May, the temperature also changes. So from 0, so you can convert this form to PDF form also. This is a report generated for a daily radiance databases. So this is it, shows here from morning midnight 12 o'clock to morning 6:45, there is no radiation at all. And the same way evening 6:45 to midnight 12 o'clock, there is no solar radiation. In between you can find the solar radiation generation, what is the daily time to time radiation you can analyze here. And the temperature also it has been given here, every day daily average temperature. In the same way, the solar radiation database can be analyzed for different websites. Hope all have understood the solar radiation database for estimating PV performance. Let's all meet in the next session. Thank you.